A long time ago, in a quiet village, there was ninja named Paichi. The village lived in peace for many centuries. But one day, the village was invaded by an evil dragon who stole Paichi's most treasured possession.
Hey man, I got your teddy bear, and well, if you want it back, you're gonna have to meet me at the top of this mountain. And also, stop staring at my weird skinny legs. I'm sensitive about it. Peace out, yo.
Paichi wasted no time and began his journey. But the journey had 4 obstacles, each guarded by an evil creature that would ask him a question. If he got it right, they would allow him to pass. But if he got it wrong, he would be killed. Paichi left the village same day and first came to bridge only to find it guarded by evil troll.
What are you looking at? Never seen a bridge troll before? Look, whatever. I'm a busy man. Answer this question and I'll let you pass. But get it wrong and I'll have to politely ask you to go back.
Paichi looked at the question and smiled, then replied, "Hui."
Alright guys, today we're going to be doing statistics, right? We're going to be covering almost every question that can come in the multiple choice paper. So it's more focused on paper 1. Alright, now first of all, right, I already covered statistics for paper 1 and paper 2, but I'm more focused on the paper 2. In a previous video, so all you have to do is go on YouTube, type in iLoveLessons and statistics, and the first series is a series of videos, right, that explain statistics from beginning to end. I'm talking about graphs, cumulative frequency histograms. It's quite long, it's about 2 hours plus when you combine all the videos, but that's a real detailed explanation for everything, right? Today, I'm going to be focusing more on the paper 1 questions, like I said. All right, so let's focus on Paichi's first answer and how he responded to get out of the situation. So Paichi was faced with the task of explaining how to deal with ungrouped data. So there are two. I like to think of ungrouped data as 2 categories. They will give you a list of numbers, right? And it's either the amount of numbers is odd or the amount of numbers will be even. I'm going to be covering both today. So let me the best way to explain this is through an example. So let's say, I'll focus on this piece of paper that's moving here. Let's say we went and asked a group of people how much slices of pizza they can eat in one sitting. So one person said they can eat 8. Sorry for the bad handwriting there, right? So one person said they could eat 2, next person said they could eat 4, another person said they eat 0 slices. Apparently they don't like pizza. So I think you get the idea here, right? So let's count how much numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we got 11 responses. So since this is 11 numbers, this is an odd amount of numbers. The reason is, so it's 11, I'll put it in brackets here. The reason is when we have an odd amount of numbers versus an even set of numbers, the working to find different things is a slightly different. Okay, so the first thing you do, whether it's odd or even, once you have the list of numbers, you have to arrange the numbers from smallest to largest. So I already took these numbers and arranged it from smallest to largest. You have to do that, otherwise you will get the question wrong. Alright, so let's take a look at the different questions they can ask you in the multiple choice. This is going to be real detailed, guys. They can ask you to find the mean. Now, some of you all have heard the word average. And a lot of you all probably heard it over and over that average and mean is the same thing. I will eventually clear this up in this video. Average and mean is not the same thing. And you can get tricked really, really easy in the exam thinking they are the same thing. So let's go through on how to find the mean first. To find the mean of ungrouped data, there's this little formula here. This funny looking E. So his name is, the funny looking E is sigma. And sigma just means to add up or to sum up or to total up. So I think you'll be able to handle the mean. The mean is you add up all the numbers and then n is the amount of numbers we had. Remember we had 11 numbers. So to find the mean, we add up all these numbers, right? So I'll just write it here, mean. Now I already added up all the numbers. When you add up all these numbers, we will get 48. And then we have to divide it by the amount of numbers we have. Okay? So 48 divided by 11, and we get roughly 4.36. Now, I made up this question on the spot before I came upstairs to tape. In the exam, they will give you, like, you won't have to divide by 11. You will have, like, probably an easier number to deal with. And I know you can't divide this in your head, right? But this is just to give you an idea of how to go about it. So, I just refreshed your memory on how to find the mean. That's probably the easiest question. So, what about the other guys? Did this formula sheet here? You see lots of formulas here. Well, there's one called Q1, right? Q1, his name is also called the first quartile. And to find the first quartile, apparently, I gave you a formula there, n plus 1, and then you divide it by 4. So let's explore how to use this formula. Now, they also write the first quartile as Q1, or some people just put first and then the word quartile, right? To save ink, I guess. So to find the first quartile, we have to take n and plus 1. What does n represent again? Remember, n represents the amount of numbers we have. Remember, we have 11 numbers in all. So we just have to take 11 and add 1 and divide it by 4. So let's take that. 11 plus 1 is 12. 12 divided by 4 is 3. Now, this is where students get tricked. They see this formula in your textbook or they see it in a video and they follow the formula and they get 3. And they think that's the answer. But if they read the textbook properly or paid attention to whatever video they were watching, you realize that 3 is not the answer, but it helps you get the answer. What they are trying to say here is the third number is the answer. So we start counting. Remember, we had arranged the numbers from smallest to largest. So we start counting until we reach the third number. 1, 2, and 3. So this is the actual answer for Q1, or your first quartile. As simple as that. All right. So the other thing they can ask you to find is Q2. Now Q2, his name is the second quartile. Right? Now Q2, second quartile, has another name, median. Right? Median, second quartile, and Q2 is the same exact thing. So in a multiple choice exam, they can use any one of these terms. And of course, you can imagine the students getting confused when they hear different terms in different exams. So the formula for Q2 or median is n plus 1, but instead we divide by 2. So let's do this calculation now. Remember, n in this question is 11. I know I'm getting repetitive, but I think I need to do it. 11 plus 1 divided by 2 is 6. So 6 is not the actual median. That's the number we have to count 2 to get the median. 1, 2, 3, 4, 5, and 6. Right, so this is our Q2. Right, so our 6th number is 4. I think you all getting the hang here now, how to use these formulas. So Q3. Q3 is your third quartile. Right, guys, I hope you're taking notes, right? Right, so it's one thing to watch a video, it's another thing, like sometimes you don't have internet access, probably you're traveling to school to the day before the exam, and you need to have your notes on you, right? So third quartile, right? So third quartile is Q3. His formula is, there's a 3 outside here instead, so it's 3n plus 1 divided by 4. Remember, n is 11. So I'm going to work out the brackets first. 11 plus 1 is 12. Going to take the 12, multiply it by 3, and then divide it by 4. And we're going to get 9. Once again, 9 is not Q3. The 9th number is Q3, provided that you already arrange the numbers from smallest to largest. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? No, I lost count there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7 is our third quartile. Great. So now we can find Q1, Q2, Q3. If they ask us to find IQ, IQ stands for interquartile range. So inter. To get the interquartile range, you have to take the answer you got for Q3 and minus the answer you got for Q1. Remember the actual answers. The actual answer for Q1 was 1 and the actual answer for Q3 was 7. Okay? So it's 7 minus 1, which is 6. So your interquartile range is 6. Right? You don't have to count to 6 for that one. This is your final answer. And your semi-interquartile range, you'll notice, is basically the interquartile range answer divided by 2. So to find your semi, S-E-M-I, like a semicircle, to find the semi-interquartile range, you just take the answer for the interquartile range and just simply divide it by 2. And you will get 3. So this is your answer for the semi-interquartile range. This is your final answer. You don't have to count to 3. The only ones that you actually do the counting for is Q1, Q2, and Q3. Alright guys, so don't worry. I know there's a lot to take in. You will get another shot at seeing me work out one, but it won't be an odd set of numbers. It will be an even set of numbers. So it'll probably stick in your head. And if they ask you to find the mode is the most popular number. Well, I think there's a tie here because the 1s appear twice and I think the 4s appear twice. So any other numbers appear? Nope. So in this case here, we have a tie. 1 and 4 both tied for being the most popular, and that's what mode means. So what would you call a scenario like this? You call it bimodal. Bi means 2. So that's another type of multiple choice question you can get, where they give you a set of numbers and you have a tie for the mode, right? 2, and they'll ask you what you call it. They'll have modal, trimodal, bimodal, or they'll have some one of the responses might make sense. You call it like median, but the real answer would be bimodal. And if there's a 3-way tie, you call it trimodal. All right, guys. So give me a few seconds, and I'm going to put the even set of numbers, and we're going to do this back, but it's going to be a little bit harder. When it's even, it's harder. All right. So let's say now we went to another place and we asked people how much slices of pizza they can eat. This time we asked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 people in all. So this is an even question now. Now, I already took the liberty of arranging the numbers from smallest to largest. You need to remind yourself to do that in the exam. So let's do the easiest one for this. Mean. Mean, you add up all the numbers. That's what sigma means. Now, I already added up all the numbers. If we add up all the numbers, we'll get 95. And then we divide by the amount of numbers we have, which is 10. So, I don't need a calculator for this. So, the mean is 9.5. Easy stuff, okay? Let's get to the harder ones now. The ones that are probably new to you. Or You didn't get enough practice in. So for Q1, I'm not going to write out what Q1 and Q2 and Q3 means. Q1 is first quartile, second quartile, or median, and third quartile. All we have to do is take n plus 1 and divide it by 4. Now here's the thing. This time n is 10. So 10 plus 1, and we have to divide it by 4. So 10 plus 1 is 11. 11 divided by 4 is 2.75. All right. So you see, we're not getting a whole number this time. I mean, if the answer was 2, you would go 1, 2. If the answer was 3, you would go 1, 2, 3, and it would be the third number. But this time it's 2.75, which means we have to count. Now 2.75 is in between 2 and 3. So we're going to count first, second, third. So that means the first quartile is in between the second number and the third number, right? Now, it's pure coincidence that the second number is 2 and the third number is 3. Sorry about that. I made up these questions when I was coming up the stairs. So, whenever the 2.7th term, whenever the term is in between two numbers, you have to add the two numbers and divide it by 2. So to find Q1, we have to take 2 plus 3 and divide by 2. 2 plus 3 is 5. 5 divided by 2 is 2.5. So Q1 is equal to 2.5. That's the best average you can get. That's the best estimate, sir. I don't want to use the word average. That's the best estimate for Q1. Let's try Q2. Q2. To find Q2 or the median is n plus 1 divided by 2. N is 10 plus 1 divided by 2. And you get 11 divided by 2, which is 5.5. So we need to look for the 5.5th term. I don't even know if that's a real word. Now 5.5 is in between 5 and 6. So let's figure out the fifth term. 1, 2, 3, 4, 5. And this here is the sixth term. So Q2 is in the 5.5 is in between 5 and 10. So we have to add these two numbers. 5 plus 10 is 15. 15 divided by 2 is 7.5. Okay, so that means Q2 is 7.5. Let's do Q3 now. Q3. Q3 is 3n plus 1 divided by 4. So we have 3. N is 10 plus 1 divided by 4. So 10 plus 1 is 11. 11 by 3 is 33 divided by 4 is 8.25. So 8.25th term is in between 8 and 9, right? That's where this lies. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 8 and here's 9. So that means it's in between here and here. So we have to add these two numbers. 17 plus 17 is 34. 34 divided by 34 is, we're still going to get 17. All right? So we have the answers for Q1, Q2, and Q3. So if they ask us to find IQ, or the interquartile, we take the answer for Q3, which is 17, and we minus the answer for Q1, which is 2.5. 17 minus 2.5 is 14.5. Remember, for these guys here, we don't have to count to the 14.5th term. Only for Q1, Q2, and Q3, you count to the actual term. So this is the final answer for interquartile. And if they ask you to find the semi-interquartile, SIQ, you take the answer you get for IQ and you divide it by 2. Semi means half, like a semicircle, so half of a circle. 14.5 divided by 2 is 7.25. So this is your semi-interquartile. And do we have a mode here? 2, 2, And yeah, for the mode, there's a tie between 17 and 2. So this one is bimodal, right? So there's a tie for it. The mode is 2 and 17 at the same time. All right, so that was it for ungrouped data. How you find all of these things here for ungrouped data. All right, guys. So let's see what adventures Paichi gets into now.
After passing bridge, Paiji journeyed for many days until he came to place that wore the stench of death, the waterfall of the damned.
Who goes there? Who dares disturb me?
Paiji was not frightened and simply told the skull his name and about his wish to pass.
Oh, well, why didn't you say so? A creepy dragon with funny skinny legs said to expect you. All right, here's your question, mortal.
Alright guys, so let's discuss Paichi's answer. So to summarize, right, I can think of a couple questions that the examiner can ask you in a multiple choice. One of them being is that he can give you a set of values, right? I'll explain the values just now, and he can ask you what's the best one to express the average. First of all, remember in the previous part of the video, I said mean and average is not the same thing. There are different types of averages. And well, the three you're going to meet up on the CXC syllabus is mean, median, and mode. These three are different types of averages. And a question that the examiner can ask you when he gives you a set of data is which one of these three guys is best suited to express this as an average, which is the best method. So A could be mean, B could be median, C could be mode, and D could be none of the above. So I'll let you know off the bat, when it comes to actual numbers that they give you, it will either be mean or median, right? I'll discuss mode last. He's kind of like the hardest to understand, to be honest. So let me describe what this data is. Let's say you want to set up a business, and the business you have, you want to sell tacos. Obviously, if you want to sell tacos, you want to open your business in a place where people want tacos, okay? So what a lot of businesses do is that they will do a survey. They will hire someone to do a survey, and when they do the survey, you will find out whether your product will sell. So let's say you have a business and it's called Mr. Tacos. I don't even know if that's real, right? So you have a business called Mr. Tacos, and you hire someone to walk around the village and ask, how much tacos would you eat? So the person you hired, and that's very important, the person you hired is going to do the survey and summarize the results for you. So let's say that he went to the village and he asked these people, he asked one person how much they eat, and they said, well, that person eats one taco. Another person said they eat 2. Another person said they're willing to eat 3. A next one said he's willing to eat 5. And the next one said, I don't mind eating 6, right? And then it have this one person who said, boy, I feel I can eat 500 tacos on a daily basis. So the person you hired decides he is going to express this information as a mean. All right, so let's see. Let's go back to our little paper here. How do you find mean again? You add up all the numbers and then you divide by how much numbers you have. So you have 1, 2, 3, 4, 5, and 6 numbers. So we're going to add up all the numbers here. Add up the amount of tacos each person responded to eating. 1 plus 1 plus 2 plus 3 plus 5 plus 6 plus 500. So when we add up all of these numbers, we get 517. And how much numbers do we have? 1, 2, 3, 4, 5, 6. 6. So 517 divided by 6, and that's 86, roughly 86.2, but that is going to round it off to 86, right? Because it's tacos. You can't buy a half a taco. So the person you hired, we will call him Billy. So you hired Billy. So Billy came back now and told you, boss, I have good news. The average amount of tacos that a person eats in that village is 86 every day. So obviously your eyes go cha-ching because you eat it. If everybody buying roughly on average 86 tacos a day and you charge $45, and every time they buy one taco, you try to sell them a sweet drink and then some fries, I think you'll make a really good profit, right? So when can you see how misleading this information is? Because he chose the mean. This gives the impression that everybody roughly eats 86, when in truth only one person is interested in plenty tacos. So let me explain what you call this odd guy. You notice everybody here is around reasonable values, and then you have this odd one out. Whenever you have a value like 1 or 2 that's out of the way, you call him an outliner, right? So he's an outliner. And anytime you have an outliner in data or information, mean is not a good method of finding the average or expressing the average. So in the exam, if you see an outliner, do not choose mean. So which one would we choose? Let's see if median is better, right? So median. Let's find the median of this information. Remember, median and Q2 is the same thing. So we fire Billy and we hire someone else. Jilly. So we hire Jilly, right? So Jilly decides to take the same information now and express it as a median. How do you find the median? You add up all the numbers. Like you add up how much numbers you have. You have 1, 2, 3, 4, 5, 6. Number Q2 and median is the same thing. So we have 1, 2, 3, 4, 5, 6. So 6 plus 1, and then you divide it by 2. So you get 7 divided by 2, which is 3.5. Now remember, when you use these here, you're looking for the 3.5th number. So 3.5 is in between 3 and 4. So here's between the third and fourth term, sorry. First, second, third, and here's fourth. The median is in between here and here, right? The 3.5th term. So when it lands in between two numbers, you add the two numbers. 3 plus 5 is 8. 8 divided by 2 is 4. So the median is 4. And if Jilly comes back and tells you now the average amount of tacos a person is willing to eat is 4, that's a more realistic prediction or estimate, because only one person is going to eat plenty, and we don't even know if he's lying, and 4 kind of generally represents the general want of the village. So when you hear 4, you are not going to waste money and set up a stall, a taco stall, because if you're going to sell on average 4 tacos a day, that's probably not going to be profitable. All right. So the moral of the story is, whenever there are outliners, median is the better one. If you don't have an outliner, mean would be the best one. So what about mode, right? Mode is used for something called categorical how I spell that? Data. All right. Actually, I spelled it here just in case I couldn't remember how to spell it. So I think you know what a category is. A category is belonging to a certain set of where everybody in that set shares something similar. This is not categorical data. Categorical data is like this. If we go and ask people what color t-shirt they are willing to buy, 10 people might say blue, 11 people might say yellow, 5 people might say pink. Each group of people belong to a certain color, and color is the category. Okay, this is not a category, you know. There's no difference in what these people want. All of them want tacos. That's just one item, one want. Okay, colors of jerseys are different. Each of them have a different color, hence they are a different category. All right, so whenever you see different categories, mode might be the best way of expressing the average. So that's basically that was basically Pai Chi's answer. Okay, so let's continue with the adventure.
After many weeks, Paiji finally made his way to the haunted bamboo forest.
Well, 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 isn't it another human cooking my cauldron?
Paiji explained he just wanted safe passage through the forest.
All right, and that's for your life story. Here's your stupid question. Stop looking at my nose, you freak.
Alright guys, so we're going to discuss Pai Chi's answer on grouped data, and we're going to see how it's different from ungrouped data. Alright, so here we have a table, and let's say that we were trying to gather information on the height of grass. So I have a table here. So you have the height of grass, so we're measuring it in centimeters. So some of the grass was 2 centimeters, some was 4, some was 6, and some was 8. F stands for your frequency. The frequency is the amount of times something happens. So let me show you how to easily interpret this. So according to the table, how many grass? Well, grass was 6 centimeters tall. Well, 4 blades of grass was 6 centimeters tall. 1 blade of grass was 8 centimeters tall. So when we were doing the gathering the information, frequency represents the amount of times something occurred. So if this is grouped data, when they put it in a nice table like this, if the examiner were to ask me to find the mean of ungrouped data, that was the last part of the video, it would just simply be sigma x divided by n. But when it's grouped data, the mean has a slight change there. It's no longer sigma x divided by n. It's sigma fx divided by sigma f. And remember, sigma just means to add up. So let me show you how to do this. What you notice your formula has an x and an f. Well, I think you figured out the f was frequency. So that's easy to understand. X is the item you are measuring. So we are measuring the height of grass. So to find fx, remember the formula doesn't have the secret multiply here. So fx really means f multiplied by x. So all we have to do is take the x and multiply by the corresponding f value, and we will get the fx values. So 2 by 1 is 2. 4 multiplied by 4 is 16. 6 multiplied by 4 is 24. And 8 by 1 is 8. So you see how easy it was to get f multiplied by x? Now, what we need to do, we need to sum up or to add up everybody in the fx column. So this here is the fx column. So to find sigma fx, we just need to add up everybody in this column. So let me add it up. 2 plus 16 plus 24 plus 8. And that will give me 50. So sigma fx is 50. So now we need to divide it by sigma f. This is the f column here. So to find sigma f, we just need to add up everybody in this column. 1 plus 4 plus 4 plus 1 is 10. So sigma f is 10. So we just need to divide the 2 and we will get 5. So the mean is 5. Look how easy that was. So this is a real simple multiple choice type of question, and you notice the numbers were very easy to deal with, just like in a multiple choice question, because you will not have your calculator. So you can expect simple values like this. All right, so I want to show you a slight twist to this question. Now we just figured out the mean was 5. Remember I just had that before I erased it. Let me show you how this question can come slightly different. Suppose, well, let me erase all of this. Let's say the examiner gives you this table and he tells you in the question itself that the mean is 5. So he comes outright and gives you the mean at the beginning of the question. So you know the mean is 5. And let's say he erases something from the table. Now we know the value here is 4, right? But let's pretend we don't know. And he erases this also. And he erases, let's say, this over here, right? And in place of this, he puts x. And he wants you to find the value of x now. So you see how the question is different? He gave you the mean. He purposely left some things out of the table and he labeled something x, and your job is to find x. So let's go about this question. The first thing we'll need to do is find the blank spots here. So obviously this means f by x, so we say 2 by 1 is 2, 6 by x is 6x. To find the mean, we need to take sigma fx. So that means we need to add up this here. But when we add this up, we notice there's an x here. So we won't get an actual value. We'll get an expression. So 2 plus 16 is 18. Plus the 8 is 26. So we get 26 plus the 6x. So I just added up everybody here. And this is the expression. Let's find sigma f now. Sigma f. 1 plus 4 is 5. 5 plus 1 is 6. And we have this plus x here. So to find the mean, which we know is 5, remember we know the mean is 5, we have to take sigma fx, which is 26 plus 6x, divided by 6 plus x. And your job, remember, your job is to find x now. So to find x, we're going to use our algebra skills and cross multiply. Now I'm going to kind of hurry this one across because I did a whole series of videos in algebra. So I'm not going to give you the baby steps on this one. So what we're going to do is multiply everyone here by 5. We will get 30 plus, well, I should clear more space here. Let me do the working over here. Everyone here gets multiplied by 5. So you get 30 plus 5x is equal to, everyone here gets multiplied by 1, which is 26 plus 6x, because anything multiplied by 1 is itself. All we need to do is get all the x's on one side, it doesn't matter which side, and all the other numbers on the other side. So we throw across positive 5x to get minus 5x, and positive 26 to get minus 26. So 30 minus 26 is 4. 6x minus 5x is 1x, but nobody puts the 1. So x is equal to 4. And remember, we actually knew the answer from the previous question, so I know I am correct. So the question before this is what I like to call a forward question. You use the formula as it is. In this question, it's a kind of reverse question. They give you the mean, and you have to like use your algebra skills and to get back the value that is missing. All right, so pay attention to both ways. anyone can come in the exam. Okay. While we're on, I know right now this part of the video is on grouped data, but there's something I missed on ungrouped data I just want to cover here quickly. So for the time being, it's a small ungrouped question. Remember, if I have 5 plus 6 plus 2, sorry, if I have 4 numbers, 4, 3, 1, and 8, and I ask you to find the mean of these numbers, remember you would just add up all the numbers and divide by how much numbers you have. So 4 plus 3 plus 1 plus 8, right? That's this formula here I'm using. This is ungrouped data. So I get 16, and then I divide it by how much numbers I have, which is 4, which is 16 divided by 4 is 4. So the mean is 4. I covered that in the previous video, one of the previous videos. But let's say we have an ungrouped question and one of these values was missing, right? And I tell you the mean is 20. So I'm telling you the mean is 20. How would you find back x? Well, to find the mean, we need to add up all the numbers. 4 plus 3 plus 8. So 4 plus 3 is 7. 7 plus 8 is 15. And we have to add the x. So we add up all the numbers and divide by how much numbers we have. We have 1, 2, 3, 4 items. So if we do this, we're supposed to get back the mean. And the examiner told us the mean was 20. So all we have to do now is cross multiply. 20 by 4 is 80, and you get 15 plus x, because anything multiplied by 1 is itself. Throw across the positive 15, you get minus 15. So x is, can't believe I'm using my calculator for this, is 65. Right? The reason I did this question is because one of my students requested it, and I now remembered that I needed to do it. Alright, so, alright, don't know his name, I just call him Tallman. Alright, so Tallman, that question is for you. Alright, so let's move on to another grouped question with a table. Alright, so let's say we're measuring something else now, the age of dogs, and this is going to be in years, and we have a frequency here. Okay, all right, so now we're not going to have one number here, we're going to have a range: 1 to 5, 6 to 10, 11 to 15, and 16 to 20. Here's going to be 3, here's going to be 2, 6, and 1. All right, let's get some questions going here now. One of the popular questions, you see when they give you a range here, this is not 1 minus 5, eh? This is 1 to 5, so it's a range. Now, sometimes to make the to get a full range, we usually need to add a certain number on this side, and we need to minus a certain number on this side. So how do you know what number to add and what number to subtract? It's very simple. You take the last number here and look at the first number here. So it's a slanted line like this, right? You can also take these two numbers or these two numbers, but never the other way. So let's just take these two. You always minus those two numbers, and no matter what, you always divide by 2. That's the formula. So 6 minus 5 is 1. 1 divided by 2 is 0.5. And you will get 0.5 if you minus these two and all and divide it by 2. Because 11 minus 10 is 1. 1 divided by 2 is still 0.5. So to all the numbers on this side, we have to add 0.5. And to all the numbers on this side, we have to minus 0.5. Okay, so I need to erase this here, right? And I'll explain why I am adding the 0.5 and minusing the 0.5. So I add 0.5 to all the numbers on this side, and I minus 0.5 from everybody on this side. 1 minus 0.5 is 0.5, minus 0.5, here I get 5.5, here's 10.5, and here's 16.5. 16.5. You see all the numbers on this side that just got bigger because I added 0.5. You call it the upper class boundary. UCB, upper class boundary. And to all the numbers where you minus 0.5, you call it LCB, or the lower class boundary. Why is this important in multiple choice? Sometimes in a question, I'm sure some of you may have come into contact with it already, they will ask you, for this one here, for this row, the one where the frequency is 2, what is the value of the upper class boundary? Well, that's very easy. The upper class boundary is 10.5. You only get the upper class boundary after you add this certain number, okay? And if they ask you what's the lower class boundary of this group, well, it's 5.5. So these simple questions can come in a general multiple choice exam. I'm sure your teachers have set questions like this for you already. So I'm just refreshing your memory, okay? If they ask you what's the range of this one, the one where the frequency is 3, so what's the range? You see, without the lower class and the upper class boundary, you might think the range is from 1 to 5, but no, the range is actually, so from 1 to 5 is actually 4, you minus the two numbers. But the range is actually the upper class boundary minus the lower class boundary. So over here, it's 5.5 minus 0.5. So the range is actually 5. So that's how you get the range, from minusing the upper class boundary from the lower class boundary for a particular group. Okay? Right, so that's some questions here. If they ask you what is the modal group, the modal, remember mode is the most popular one. Which one has the highest frequency? Which age of dogs was the most popular? That would be the 6. But the answer is not 6. The answer is what the 6 is referring to. So the modal age is from 11 to 15. And you should see that somewhere between A, B, C, and D. So when they ask you for the modal group or the mode, they're not referring to the actual frequency. They're referring to the biggest frequency and the group represented by that. So don't fall for those simple tricks, because they will put the 6 between A, B, C, and D. They know the kind of tricks students fall for. All right, so those are the kind of questions you're gonna get. There's a harder version for this question, but it's not gonna come for the multiple choice, in my opinion. But like I said, I did a whole series of videos on statistics. That's a real detailed one, right? And I showed you how to find that already. All right, so I'll cover the upper class boundary. Oh, I want to show you a small trick. All right, so when students do a question like this, right, and you have to find the upper class and lower class boundary, you see how we get 0.5 here? Most of the times, when you minus these two numbers and divide by 2, you will get 0.5. 99% of the questions. So you're adding 0.5 on this side and you're minusing 0.5 from this side. And from form 3 go to form 5, you did so much questions like this, you automatically think it's always 0.5 added and subtracting. Here's a trick question. So suppose now it's something like this: 1 to 10, 10 to 20, 20 to 30. Let's call it short there. You get this question here and they ask you to put in the upper class and lower class boundary. And students just start to add 0.5. So they put 10.5, 20.5, 30.5, 0.5, 9.5, 19.5. Look at this question. If we take these two numbers and minus it, remember we have to divide by 2. And 10 minus 10 is 0. 0 divided by 2 is 0. So that means we don't have to add 0.5. We have to add 0. So we're adding nothing to this side and minusing nothing from on this side. So this is actually, well, I'm not going to put 10.0, right? So sometimes you do not have to add 0.5 and minus 0.5. Sometimes it ends up being 0. So please check. Don't assume it's 0.5 all the time. All right, so I think I covered a lot of questions there on grouped data. Just double checking to make sure I haven't. Oh, here's a good question. All right, so let me put back some let me go back to one here. How many? That's what I'm making sure. How many dogs were less than 21 years? All right, there's an easy version and there's a hard version here. So age of dogs. Let's go with 5 years, 8 years, 10 years, and 12 years. All right. So this is the easier one without the group. So 2 dogs were 8 years old. If they ask you, how many dogs were less than, remember this is the symbol for less than, right? Less than 10 years. What would be your answer, right? So 3 dogs were 5 years, 2 dogs were 8 years, 6 dogs were 10, and 1 dog was 12. Less than 10 years means, remember, less than is different from less than or equal to. Less than 10 years is 8 years and 5 years. So how much dogs were less than 10 years? 2 plus 3, which is 5. That's the amount of dogs less than 10 years. But if they put less than or equal to, that means the 10 is equal to the 10, and you have to accommodate everyone less than that also. So less than or equal to the 10 years would be 6 plus the 2 plus the 3. Okay? So that will be 5 plus 6, which is 11. Please don't fall for this trick in the multiple choice or even the long paper. Okay? Less than and less than equal to are different. So I think I cleared that one up, right? All right. So I just want to show you a question that can come in the grouped data, and they give you like the ranges here, right? The groups. So this one goes from 1 to 5. Okay. So there's just a point I was making. One thing I think I probably said wrong. I can't remember. It's kind of late in the night and my memory kind of is fading here at the moment. I think I referred this to as 16 to 20 and 11 to 15 as groups. They're already ranges, right? So this is a range from 16 to 20. I think I kept saying groups over and over. All right. If they ask you how much dogs were less than 16 years in this one, less than 16 does not include the 16. So you have to start counting from behind the 16. So everything less than 16. So less than 16 would be anyone from 11 to 15 years, 6 to 10 years, and 1 to 5. So less than 16 will be 10 plus 2 plus 5, which is 17. 17 dogs were less than 16 years, right? To my knowledge, they won't ask you, and I don't believe they can ask you this question. You don't have enough information to answer less than or equal to 16 for this particular table. All right, so when you see the ranges like this, the most they will ask you is less than something, not less than or equal to something. All right, so I believe I covered all the different types of questions that could come on grouped data. All right, so let's continue on with the adventures of Paichi. All right.
Hello, my friend. Welcome to mi casa. El dragon told me to expect you. Here's your question. If el correcto, you get to paso. But if el wrong, I eat your family. Paichi looked at the question and grinned. he knew his passage was secured.
Guys, so let's discuss finding values of a cumulative frequency. Now, I've been getting a lot of messages regarding multiple choice style questions regarding cumulative frequency. So I'm going to spend a good bit of time on this. Let's say we have a cumulative frequency in your multiple choice. So the examiner is obviously going to draw the full graph for you. Not a, that's definitely going to be given to you. So he can obviously ask you to find things like, remember this paper, Q1, Q2, Q3 and whatnot, and IQ. So I'm going to go through how to find these values of the cumulative frequency. First of all, right, here we are measuring the age of turtles, and this one is your cumulative frequency. So can you tell me how much turtles was involved in this survey? Is it 50, or is it 100, or is it 120? First of all, let's clear that up. This axis tells you the age of the turtles, not how many turtles. The y-axis tells you something about frequency, cumulative frequency. So when you hear the word frequency, that is referring to how much of something you have. So you're more likely to find the amount of turtles on the y-axis. So is it 100 turtles or 120? It's a common trick in the exam. Your graph here goes up to 120, so you might think it's 120 turtles. But look at this graph. This graph only goes up to 100. So it's really only 100 turtles involved in this survey that we're doing, right? So don't be fooled by that. And when you're using these formulas, right, N is the amount of turtles involved. So when you see N here, it refers to the 100, which is the amount of we're dealing with. Now, in today's question, it's a nice easy number, 100, right? It won't always be 100, obviously, okay? So just letting you know here, N represents the cumulative frequency in this graph. Now, I'm going to put this here next to the formulas I plan to use. You notice they're slightly different. For Q1, it's just N divided by 4. Where did the 1 go? Where did the 1 go for Q2? Where did the 1 go for where did the 1 go for Q3? It's like I just threw away the 1. The thing about it, whenever your cumulative frequency is more than 60, and in this case here, the amount of turtles is 100, which is more than 60, as a general rule of thumb, you can exclude the 1. And it won't affect your answer. So, because I'm dealing with 100, to make my calculation simpler, and remember for multiple choice, you will need to, because you will not have a calculator, eliminate the 1 from it to make the formulas simpler. So how do you find Q1? Well, you take N and divide it by 4. So it's 100 divided by 4, which is 25. Now here's the thing. A lot of students will think that 25 is the answer for Q1. No. To get Q1, you have to look for 25. So 25 will be somewhere around here, right? 10, 20, 30, so 35. You go straight across, let it hit the graph and let it fall down. And the number it falls on is Q1. So that means, I'm going to write it here. Q1 is, I'm just going to approximate it here. Let's call it 12. Let's call it 13, right? I don't have an accurate graph here. So to find Q2, we take N and divide it by 100. Remember N and divided by 2. So N is 100 and we divide it by 2 and we get 50. Once again, 50 is not the actual Q2 or median. You're going to use that to find it. So you're going to go up, find 50, go across, let it hit the graph and let it fall straight down. So it seems that it falls somewhere for Q2. We get roughly 20. I'm going to call it 22, right? And Q3 is a similar thing. It's 3 by 100 divided by 4, which is 75. 75 once again is not the answer for Q3. You look for 75, right? Let's assume here's 75, and we go across, let it hit the graph and let it fall straight down. So let's assume you don't have space here. So Q3 is going to be 30. These are the actual answer for Q1, Q2, and Q3, whatever it falls on. If they ask you to find the interquartile range, remember that formula? Q3 minus Q1. Q3 minus Q1. Remember, you're taking the actual answers for Q3 and minusing the actual answers for Q1. Not these guys, you know, the ones that it falls on. A lot of students fall for that trick. So what some of the students will do by mistake is take 75 and minus 25. That is wrong. Take the answer for Q3, the one it fell on, and minus the answer for Q1, which is 13. So if we minus 30 and 13, Lord, 30 minus 13 is 17. So your interquartile range is 17. And to get your semi-interquartile range, you take your interquartile range, which is 17, and divide it by 2. And that will give us 8.5. Guys, this question is really popular. Not only in a multiple choice, but in a long paper. And you see how students can easily minus or use the wrong values by mistake. Some of these values, you're using it to get the actual answers. Okay? And after you get the actual answers, they can ask you to do certain things like interquartile range and semi-interquartile range with the actual answers. So, if you didn't take proper notes, here's my advice. Rewind the video, draw back everything, and make proper notes. You will not regret it. Okay? Alright. So, give me a few seconds. I just want to show you a couple other things with the cumulative frequency involving this word, less than. 1 second, guys. Alright. So, let's talk about 2 more questions that can come with the cumulative frequency. Here's the question. One of the questions. How many turtles are less than, keyword less than 35 years? In a cumulative frequency, whenever you are reading a value off the y-axis, it only gives you less than information. That's why I have this note here. So to figure out how much turtles are less than 35 years, you look at the x-axis, because the x-axis tells you the age of the turtle in years. All we need to do is look for 35. So 35 is here, and this time we are going upwards. So we go upwards, and wherever it hits the graph, we go straight across. So let's average this value. I think this is around 85. So 85 is the actual answer for this question, because they ask for less than, and the y-axis, once we read a value off, is automatically less than. So no tricks in that question. But suppose they ask you not less than. I'm going to change the word to more than. Remember, your y-axis doesn't tell you more than. It only tells you less than. So if they ask you how many turtles are more than 35 years, well, you do the same thing. You'll find 35, you go up, and it hits 85. But whenever it's a more than question, you see the number it lands on, you have to minus that from the total amount of turtles. And the total amount of turtles is 100. So the final answer for this question is 15. There's an easy way to remember it. When it comes to cumulative frequency, the less than, you read the value of the y-axis and you take it as it is. So for less than, you have to do less work. When it's more than, you have to take the answer you get and minus it from the total. So for more than, you have to do more working. You have to do one extra step. So I hope that helps you remember how to handle more than and less than on cumulative frequency graphs. Common trick in the exam, guys. I'm telling you. And I have one more thing I want to do regarding the histogram. there are a few questions you can do on the histogram, but I just want to do one common one. If you remember, the histogram is the one with a little building stacked next to each other. So it's something like this. You have little blocks like this, right? And what they can ask you to do is find something called the mode. To find the mode is real simple. You look for the tallest block. The tallest block will be bordered by two shorter blocks. You see where this one touches the taller block, where this building touches the tallest building, the point of touching, draw a line from here to this corner. And where the other building on the other side, the shorter one, is touching the taller building, which is here, draw a line to the other corner. Where the X meets, drop it straight down. And the number it falls on, the actual number it falls on, is the mode. Okay? So this works when you have, so to recap, find the tallest building. The tallest building will have two shorter buildings touching it. Draw X. And where the X meets, drop it straight down. Now there's a harder version to this one. So let's find the mode of another histogram. Okay? Let's say the histogram was like this now. So you had one here, had one taller, you had a shorter one here, shorter one here, and then a really tall one. But you don't have a block on the other side. So they ask you to find the mode. To find the mode, you look for the tallest block. The tallest block is supposed to have two buildings touching it, but only one building on this side is touching it. There's no building on the other side. So that means it comes like the only thing you have is the ground. So the ground is touching it over here. So you draw a line from here to this corner and a line from here to the other corner. Where it meets, drop it straight down. And the number it falls on is the mode. Alright guys, so I think I covered basically every trick question that can come in statistics.
Whoa, 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 hold up. What do you mean you covered everything? Man, this is a classic case of YouTubers embarrassing themselves again. Firstly, this video didn't cover any standard deviation or bar charts, and I didn't even see a single pie chart. For heaven's sake, make a part 2 to this video. Jeez. Alright, I got that off my chest. Now let's see how this pie chart crap ends.
Despite the many obstacles, Pai Chi made it to top of mountain, and as promised, the dragon was waiting patiently.
Hey man, I see you made it. Whoa, I really was hoping you would have died. Alright, so anyway, here's your teddy bear. Alright, I guess that's it. I'll just go back to my mountain by myself, all alone, with no one to hug. Alright, bye, Mr. Teddy Bear, I guess.
Pai Chi saw the sadness in the dragon's eyes and felt compassion. So Pai Chi then wasted no time and ended his enemy.
Oh God, Mr. Teddy, remember me.
Pai Chi returned to his village the next day and told the story of how the mountain dragon captured and tormented him for many days and refused to give back the teddy bear. He told them of how the dragon threw shurikens at him while his back was turned, and that the dragon had no honor. And so the village was safe once more, and the legend of Pai Chi lives on.